Solving for x here, remember that, like, you got to figure out what it is. That's the approach you got to take. So when you look at number 1, there is no word log there, right? Which means 2 things. 1, it's exponential, and 2, I don't have to check the answer. So for number 1, I would add the 3 to the other side. In a color you can see. Add the 3. 2e to the x would equal 13. Divide both sides by 2. And I get e to the x equals 13 over 2. It's exponential, but I cannot change the base to be the same thing, which means I do what? You're going to ln both sides of the equation. So ln here and ln here. Ln of e to the x just becomes x. And then without a calculator, that would be my answer. With a calculator, it would be ln of 13 divided by 2. And we're going to round to 3 decimal places on the test. So this would be 1.872. So without a calculator like that, with a calculator like that. I'm pretty sure this one's on the calculator part. All right, 2 has the word log in it, which means we're going to approach it by the log way. But 2, it means I have to check this answer. So the first thing I'm going to do is identify, first of all, there's only 1 log on one side, right? So I'm going to convert it to exponential. The base here would be 10. 10 comes over and picks up the 2, drops off, and leaves it as 4x. I'd get 100 equals 4x. Divide both sides by 4. And x equals 25.
So even if you don't have 2 answers, you have to check it.
Yep. So you're going to check here just to make sure it can be done. 4 times 25 is a positive number, and I can find the log of a positive number. So I get to keep it.
And that's only for log. Do you have to check?
Or ln, but yeah. Because ln is a log. Yeah. No. You have to isolate it first. Yeah. So it's like, pretend as though those are in parentheses. It's a protected little package, and you can't break it up until you get rid of the log on the front. Okay, then 3, I've got more than 1 log on one side of the equation, so I'm going to condense it. This is addition, which means I'm going to turn it into what? Good. Log base 3 of 5 times x plus 2 equals log base 3 of x plus 6. If there was only a log on one side, I would convert this into exponential. But there's a log on each side, which means I literally get to ignore the log, and I set 5x plus 2 equal to x plus 6. Distribute this, and I get 5x plus 10 equals x plus 6. Subtract the x. I don't know why I put positive 6. It's just 6. Subtract the 10. Divide by 4. X equals negative 1. It had a log in the beginning, so I have to check this one. I'm going to come back up here. Everywhere there's an x, I would plug in a negative 1. So negative 1 here gives me 1. I can find log of 1. Negative 1 here gives me 5. I can find the log of 5.
If it was 0, it never works, right?
No, not never. 0 would have worked in that.
So
You mean when you plug it back in?
When is it that, like, the number doesn't work that way?
When you plug it in, if that number is 0 or negative, it doesn't work.
Like if you have to find the log of
0, right, or a log of negative. Log of negative you can't find, and log of 0 you can't find. Yep. And notice that didn't require a calculator, right? So this could be on the part that doesn't have the calculator. All right, questions from homework before we get into the review? All right, so this is there's 2 logs on one side of the equal sign. So you can actually do this 2 ways. I can move the ln to the other side and use 1 to 1. Or I can condense, but I'd get ln of x over 6 equals 0. Ln is log base e, x over 6 equals 0. E picks up the 0. E to the 0 equals x over 6. E to the 0 is 1. And I get 1 equals x over 6 multiplied by 6. And x equals 6. And then you check, can 6 be plugged in there? The answer is yes, so that's my answer. Again, I could have also moved it over here and used the 1 to 1. X would have equaled 6 from the get-go. Yeah, it won't be that easy on your test, though, so don't get used to it. It won't be a 0. Okay, 6 log base e of 3x plus 4 equals 5. E comes over and picks up the 5. I'm going to subtract the 4. and then divide by 3. So I could do it like kind of in a multi-step on my calculator, subtract 4, and then take that answer, divide it by 3. The only reason I would say to kind of keep it like that is you don't want to do e to the 5th, round that, then subtract the 4, then divide by, you want to keep it exact. So if I did e to the 5th minus 4, I get 144 divided by 3, and I get 48.138. So if it's in the rounding, depending on your steps, I may or may not take off. If you literally round wrong, I'm going to give you points off. But if you like rewrote this as 148.4 or something like that, you rounded it, then it's going to give you a different answer at the end. It wouldn't be as exact. So if you're going to round, keep the 3 while you're working. All right, the last one has multiple logs on one side, so I got to condense it first. So it would be ln of x plus 2 over x minus 4 equals ln of x. You're welcome. If it was a single number on the other side, I would do e to the power equals that fraction, but this time I get the 1-to-1. So I ignore the ln's and I rewrite it as x plus 2 over x minus 4 equals x. I'm going to multiply both sides by x minus 4. These cancel. I get x plus 2 equals x squared minus 4x. As soon as you see the squared and the x, you should know you're going to have to factor. So get everything to one side. There are not factors of -2 that sum to -5, which means you have to do the quadratic. So a would be 1, b -5, c -2. -5 plus and minus the square root of b squared minus 4 times a times c, all over 2 times a. 5 plus and minus the square root of 25 plus 8 over 2. 5 plus and minus the square root of 33 over 2. And then 33 doesn't break down at all. So those are your answers. Yep. And you could check, right? So I would say 5 plus square root 33 is in between 5 and 6. So make it like a 5 point. I would even make it even. 5.6 over 2. That's 10.6 over 2. 5.2, which is fine here, and fine here. The other one is 5 minus 5.6 over 2. So that's a negative 0.6 over 2, which is a negative 0.3. When you plug in the negative 0.3 in here or here, it doesn't work. So you keep the 5 plus square root 33 over 2. That's the only one you can keep. I don't think so. I'm trying to remember. I think they're all factorable. At least the ones that will be given on the day of the test. Haven't made your makeup yet. Yep.
Oh, you wouldn't have to.
All right, so we're going to go through the note. Okay, we're going to kind of go through the topics. There's some examples built in here, and then your job is to work through the PDF review. So it is 3.1 to 3.4. You do have to have a calculator. I think we said yesterday, was there 18 questions, I think is what I looked up. There are some non-calculator and some calculators. So the graphs of not involving E are going to be on the non-calculator part. The one-to-one properties are going to be on the non-calculator part. Condensing, expanding without like actual values would be on the non-calculator part. And then the rest of it's going to be on the calculator part. So we started in 3.1 with the graph of exponential. So remember exponential graphs are something like f of x equals 3 to the x, or f of x equals 1/3 to the x. They could be fractions or they could be whole numbers. For these, they have a horizontal asymptote, and it's based on the vertical shift, which means they are y equals equations. You are going to have a y equals. You are not going to forget that, because if you do, you lose the point. Yeah.
Graphs with like e in it are exponential, right?
Yeah.
Because they're not log or
Correct.
ln. So this applies the same.
Yep. So this would also be an f of x equals e to the x. That would be exponential. Yep. The domain on these are all real numbers. And the range also depends on the vertical shift. It would usually be that to positive infinity. So in like the world of exponentials, it can flip. But in what we have done, they cannot. They have not. And then you'll also get asked for the y-intercept, which is going to be when x is 0. It's going to be the middle point on your t-chart if you've done it. They are set up very similar to your quiz. It's going to ask you for all the parts. It's going to give you the t-chart. You got to plug it in. And then obviously graph it at the end.
The same as the quiz, like the
Same format. Mm-hmm. So if it's not an E base, it's going to be without the calculator. If it had an E as its base, it would be with the calculator. All right, there are word problems in this that are just exponential. So these things are like something with decay or something with growth where you literally just have to plug in the value for x and you figure it out, okay? So it would say something like the population growth of blah, 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 blah equals, and it gives you an exponential function like y equals 5e to the x. And then it says what happens, or actually it would be a variable like t. What happens when t is 3 or in the third year? You literally just plug it in and let your calculator do the work. Yeah. The interest problems are going to be just like they were on the quiz, where you're going to have to know if it's continuous or if it's number of times a year. If it's continuous, it's your PERT, A equals P times E to the RT. And number of times a year, A equals P times 1 plus R over N to the NT. And this is money, so you're going to round it to the nearest hundredth, and it's not going to tell you that. That's common sense that you need to know. I had 3 people throughout the day ask me how many weeks in a year. I'm not going to give you that information. Okay? Huh? 52. Yes. So no. If it's yearly, it's once a year. Semi-annually, twice a year. Quarterly, 4 times a year. What else? Monthly, 12 times a year. Weekly, 52. Daily, 365. We're assuming it's not a leap year. Okay? So all that stuff you got to know. Then 3-2 was your log functions. Okay? Again, you're simplifying the logs, and that's all the mental math stuff. So all the little stuff on the right-hand side here, you would be able to do without a calculator. If it is log base 3 of 3, what's my answer? 1. Log base 3 of 1. 0. Log base 9 of 3. So close. How do I get from 9 to 3? 1/2. It's a square root, right? Which is 1/2. 3 to the 1/9. -2. Log base 3 of 3 to the 4th. 4. ln of e to the 4th. 4. ln of e, log base e of e to the 4th. 4. E to the ln 4. 4. 3. Log base 3 of 4. 4.
The one before the last one, is because the ln and the e cancel, right?
Right. If it was e to the log base e of 4, the base on the exponent's the same as the base, right? So they cancel out. Okay, then we get into graphing the logs, right? So the log shape is that. It's the curve that increases as you move to the right. It's almost like a square root, except it has an arrow that points down. This is going to be something like, so f of x equals, and it's going to be log of some base, x plus and minus a number. It could have a vertical shift f after. Or f of x equals ln of x. It could have a plus and minus in here. Plus, or let me actually just write it. Which is your horizontal shift, which causes your vertical asymptote to shift. So this has a vertical asymptote, okay, and it shifts with the parentheses or the horizontal shift, okay. We find it by setting that equal to 0. The domain shifts with the parentheses. We get it by that same value. If it points to the right, it'd be to positive infinity. If it points to left, it would flip it. Range on these is all real numbers. And this time we have a x-intercept because we plug in for y. Yeah.
For logs, we always set like it equal to 0, and for exponential, it's just whatever it shows us.
Correct. And that's y equals. So like if you forget if it's supposed to be x equals or y equals when you go to write your equation, think about your logs. Your logs equation literally says x in it, and you set that equal to 0. So that answer is always going to be x equals something. And then the exponential would be the opposite, which is the y equals. So again, with the graphs, if it's a log, there will be no calculator. And if it's a ln, you would have a calculator because that would be log base e. There are 7 versions of that quiz out there between the 3 classes and the makeup. Feel free to find other examples by asking around, okay? And you can graph all of them. There's obviously stuff on your test review, but there's also all of those floating around there. So find friends. All right, then 3.3 came the properties of logs, condensing and expanding. If it's a product, when we split it, it becomes addition, and vice versa. If it was split and we put it together, it would become multiplication. If it starts as a fraction or division, it becomes subtraction. Or if it started subtraction, it would become division because it can work both ways. And if it's raised to a power, that power goes to the front. Vice versa, if there's a number on the front, it becomes the power. Yeah. All right, so when I expand log base 3 of 9x to the 4th, because it's multiplication, it would become addition. So I'd end up with log base 3 of 9 plus log base 3 of x to the 4th. The log base 3 of 9 becomes 2, and the 4 bumps to the front here. So be 2 plus 4 log base 3 of x. If I have log base 3 of 18, x to the 4th, this would be log base 3 of 18 plus log base 3 of x to the 4th. Now, 18 is not a power of 3, but can I break 18 down to be something that's a power of 3? Yep, what would it be? 2 and 9, excuse me. So that actually would become log base 3 of 2 times 9. Which breaks down to log base 3 of 2 plus log base 3 of 9. And then this 4 bumps to the front here, so plus 4 log base 3 of x. Now can I simplify part of that? Yep. Log base 3 of 9 becomes 2. Log base 3 of 2 plus 2 plus 4 log base 3 of x. So that time the breakdown wasn't as obvious because it's not flat out a power of 3, but you can continue to break that down. So make sure you check for that. I would say anytime there's a number there, check to make sure it couldn't be broken down. All right, then log base b of x to the 3rd, y to the 3rd, x to the 2nd, y to the 3rd, b, and then a to the 4th. Everything in the numerator gets a positive, everything in the denominator gets a minus. So this is going to be log base b of x squared plus log base b of y to the 3rd minus log base b of b minus log base b of a to the 4th. All the exponents bump forward. 2 log base b of x plus 3 log base b of y. Log base b of b is what? 1. Good, minus 1. Minus the 4 bumps to the front, 4 log base b of a. Good morning.
Morning. Good morning, everybody.
Yep.
For the second one, can you explain what you did with the 18?
So if I have a number there, like I'm going to always check to see, obviously 3 can't be raised to a power to get to be 18, but are there products of 18 that I can, which is 9, right? So if I break it apart into 2 and 9, I can actually simplify the log base 3 of 9. So just make sure you check if it's a number there. Can I break that down into a factor of the base? And then you want to split it. Okay, the next one, I'm going to condense. So I've got negative 4 log base b of a plus 2 log base b of y minus log base b of b plus 2 log base b of x. So if I condense this, I get basically back to where I was here. Log base b of a to, the a to the 4th would be in the bottom. B. The y to the 2nd would be in the top. The b would be in the bottom. And the x squared would be in the top. So be able to get from one to the other in either direction. 3, 3 is where we did change of base. Remember, change of base is the number that is bigger in physical size and not value in the top, and then the base goes in the bottom. So this would be log of 3 over log of 4, which is ln of 3 over ln of 4. Without a calculator, you would be leaving it like that, and then with the calculator, you would actually divide it out. Log of 3, or ln of 3 over ln of 4, or log of 3 over log of 4, and you should get 0.792. You did pretty good on the quiz there. I think maybe 1 or 2 people throughout the whole day reversed it, so just be careful. Remember, base, bottom. So whatever's here goes in the bottom. And then we are where we started the day in 3, 4. So the first kinds are 1-to-1. They're either going to be exponential 1-to-1, logs 1-to-1, or ln 1-to-1. And in all of these cases, we ignore the base and set the exponent equal to each other. So this would be x equals 3. Ignore the logs. This would be x equals 3. Ignore the ln. And that would also x equals 3. So that is the 1-to-1 property, either exponential or log or ln. They all do the same thing. All of that would be non-calculator. Then came exponential, and this is where you can't change the base to be the same, so we ln these, right? ln, this would be ln of e to the x, which is x, equals ln of 10, 2.303. We ln both sides of the equations here. The x bumps forward, and we would divide both sides by ln of 2. You're welcome. Have a good weekend.